Welcome again to PyBay. It's really, really great to be here. This is my second PyBay, and there are so many things I really like about PyBay. And there's a couple of them which I really want to point out. The first one is the sense of the community, which is really, really strong here. Most importantly, there's a lot of learning, and it's a great opportunity to meet new people. So I have one request for you during these next days. Please thank your speaker. Let's be grateful for them sharing their knowledge. It's always very flattering and encouraging when you directly hear that someone has appreciated your talk. So during these next 2 days, if you hear something interesting, please go to them and thank them, because it's just very, very beautiful. Okay? So today, what are we going to be doing? Lightning talks. What are lightning talks? Who knows what lightning talks are? All right, well, 99.9. But let's just recap what lightning talks are. They're 5-minute talks. We have some today, Friday, and we have some on Sunday. Most important, they're a really safe space to pitch new ideas. If you have some interesting thing you want to speak about, those 5 minutes are a great opportunity for you to do so. It's also a great opportunity to get feedback on your project. If you have like your pet project and you want to show it to the world, those 5 minutes are a great opportunity. Most importantly, good humor. So if you have interesting pictures of dogs or cats, they're very welcome, all right? One last thing I wanted to say is we want you for Sunday's lightning talks. So we still have a few slots for Sunday. Outside, just around the corner over there, there's a board where if you want to pitch your topic, just write it down, write your name, the title of your talk and your email, and then I'll make sure that I contact you after. It would be really great to have you there. So, without further ado, today we have 10 of the most finest lightning talks. Yeah. All right. So without further ado, may I have Eric Mendez up on the stage and Sarah Schotshiner to come up next. All right, ladies and gentlemen, let's give a great round of applause for Eric.
All right. Hello, I'm Eric. I work for a little company in Oakland. We're called Comfy. We make a software platform that helps you have like a great experience at your work. Like you can change the temperature and book a conference room. But anyway, we run Kubernetes and we use a lot of Python. And here we are at the Python conference. So who knows Docker and Kubernetes? Or Docker? Yeah, basically everybody. Kubernetes. Yeah, almost, right? So you got a lot of Docker containers. You want to run them somewhere. You need something to help you do that. That's Kubernetes. You take a Docker image and a bunch of YAML. You put it together. It's your Kubernetes object, and you're going to put it into your Kubernetes cluster, and it takes care of running it, running those things in different ways. We call them Kubernetes objects. And Kubernetes land, for example, just a couple examples, you could have a deployment. It means take one or two of these containers and run them just somewhere, however you want. Or a daemon set. Take one container, run one copy of this container on every host or node in my cluster. So what does it got to do with Python, Kubernetes, written in Go? Boo, Go, not Python. The Kubernetes Python client, you can talk to Kubernetes with Python. You can use this Python client to do things to talk to your cluster, but more excitingly, what you can use the Kubernetes Python client to extend Kubernetes. You can make a custom Kubernetes object in recent versions of Kubernetes, which lets you make your own instead of a deployment or a daemon set or one of the variety of other object types. You can make your own object type. And what does this look like? It's some YAML and a Docker container. You put them together, and it might look like this. For example, let's say I wanted to find some way to test out custom objects in Kubernetes. One thing I thought of is I'd really like to get my Docker images to pool to my nodes faster. We all know Docker images get pretty big. It takes a long time to pool them. And if I'm trying to do a deployment, I'm going to kind of want that to happen as fast as possible. Maybe I've got like 10 or 15 containers I want to get running in my cluster, and all the different nodes are going to have to pull them one by one. And maybe I got to migrations I already ran, and so I kind of just want to get all my containers up to date as fast as I can. So wouldn't it be nice if I could pull all these Docker containers to my worker nodes in my cluster ahead of time before I go and do any deployment? So I thought I would try this out. So you can see I made a custom resource definition. I define my own image Kubernetes object.
I've got
it's
a
pretty
series
simple.
Of things.
It just give it a name and the image name and tag I want to pull. And you can see I can then go make on the right-hand side. This is how I create one of these images in my cluster. And it's a YAML file, and I use the Kubernetes client to go and put that into Kubernetes. And how does all this work? There's a controller that I run in Kubernetes. It's its own Kubernetes object, and it listens for these changes, and that's how I can do that with Python. Here we go. It's a little long. It's a little small. But the first half of this file is mostly just boilerplate. Like I get my clients and credentials, and I get everything configured so we can zoom in. There we go. And here's the real meat. You can see how simple it is. It's so easy. The Kubernetes client gives you a nice, easy streaming iterator over all my objects in my cluster. Every time I create an object, this watcher is going to return that object to my controller, and I can do things with it. It just gives me a nice big dictionary describing what just happened, like was my object added, was it deleted, was it changed or updated, and then it gives me the object itself as a dictionary. It looks just like that YAML blob we saw in the last couple slides. And this controller is pretty simple. It goes and checks, it sees, and there we go, line 43, making sure I actually defined what image I wanted to pull, and I go and I use the Docker Python client to pull that. And then I'm going to go just make a little annotation on the object itself to let me know this node is done pulling. And what I can do is I can take this controller, it's just another Docker container, I'm going to run it as a daemon set, so it's going to run on every node in my cluster, and each one of those containers will get notified when a new image is created, and I'll pull it down to the cluster. And that's about it. This is pretty simple. I owe a lot of thanks to this blog post, OpenShift. Most of the original thoughts on this talk came from there. And this is up on GitHub. You can check it out. And I sure could use some help making this talk more interesting, so we're hiring. Come find me after.
All right, thank you very much, Eric. All right, so our next speaker is Sarah Schatzschneider, and thank you, and please have Jacob Perkins nearby, ready to present. A round of applause for Sarah.
Can you hear me? Oh, you can. All right. All right. Hi, everyone. I'm Sarah Schatzschneider. I'm a software engineer at Blue Apron on our data engineering team. And I'm going to be talking to you guys about APIs and Airflow and piping hot data from third parties to your party. Hope you like the pun. All right. So many of you will recognize this as a cron tab. Cron jobs will run a specific task or script, so command or script, at a specific time. And yeah, it works well, but Airflow is better because right off the bat, you get the same functionality, but a lot more. You get monitoring, alerting, a fancy UI. You know when things are broken. It's great. Anyways, before I jump into more about what Airflow is, I want to make sure everyone in the audience knows what a DAG is, so a directed acyclic graph. So you have nodes and you have arrows. So you can only go from left to right in this picture. So each node in this is a task, and that's an operator within Airflow. And then our edges are the dependency structure. So in this example, which is very high level, we are going from taking data from an SFTP server, putting it into GCS, then moving it into BigQuery, and doing a final transform within BigQuery. I just wanted to point out that you can use a lot of different third parties in your workflows, and this is a very small section. There are many more, so definitely check out the GitHub repo. And then this is a screenshot just showing how complex the DAGs can get, and it makes these really complex tasks simple and very easy to maintain. So now, what is Airflow and why do you want to know about it as a Python developer? So first off, Airflow was created by Airbnb and open sourced in 2015. Airflow at Blue Apron, we are using it for an efficient way to perform ETL, so to extract, transform, and load your data from one source into either one or many destinations. So in Airflow, you can programmatically author workflows, which are made up of the specific tasks that we saw before. You are able to, because of the tasks and the directed nature of the workflows, you are going to have stateful scheduling. So your task is only going to run once the dependencies upstream are met. Airflow comes with a really rich CLI and user interface, which is extremely helpful for understanding what's happening in your DAGs currently. And another way to understand what's happening is all the logging, monitoring, and alerts. So you'll actually know when something fails. In a cron job, you would have to do a lot of custom stuff, which is a pain in the neck. And then because of the nature of having the tasks, it keeps it very modular and so very highly testable, and it solves a lot of common problems with batch processing. So all DAGs are written in Python. This is a very simple hello world DAG, but it gives you the idea of how flexible it is. We are able to say when we should email, if it's on failures, if it's on retries, how many times you should retry before a task is a failure, when it should start, and how often it should run, along with many other things. So within the tasks, those are the Airflow operators, and this list barely scratches the surface. I was just trying to keep it simple so you could get an idea of what's happening. But the one I definitely want to call out is the Python operator. This is awesome because you're able to call a Python function within the Airflow environment. So you get all of the logging, monitoring, and alerts on failures within your workflow. And then trying to understand why should you use Airflow, what value does it add? When it comes to Airflow and errors, it will be able to elegantly retry. So anytime there's a transient network error, you're not going to get alerted at 2 a.m. It's going to retry and then hopefully get past that transient error. DAGs will be configured to either send emails or Slack alerts on the failures, which is great, so you know what's happening. When you have to rerun a specific part of a DAG, you can run from that failed task instance. You don't have to run the whole thing. And then, so that's a huge time saver. And then Airflow does support distributed execution, which you can have multiple machines contributing towards the same jobs. And real quick, just going over the UI. So you get awesome metrics. On the left-hand side is the Gantt chart showing all the progress. So the light green are tasks running, and dark green are successful. On the right-hand side, you have the task duration showing how long tasks have taken in the past, so you can understand how much longer they will take. Overall, Airflow enables ETL jobs to be more readable, maintainable, and actually really fun to develop. Thank you.
Thank you, Sarah. That was really great. Hopefully we'll move to Airflow soon. All right, so our next speaker is Jacob Perkins. And please, Sai Rampal, come up next. Without further ado, Jacob Perkins.
Jacob. So I want to do a brief overview of some of the natural language libraries that are available in Python and some of the interesting concepts. So first is tokenization. You've got a bunch of text. You need to break it into words. This is a core building block of NLP. So first you break it into sentences. Then you can break those sentences into words. NLTK and Spacey are both really good libraries to start with. Both have tokenization plus a lot more. So the thing with tokenization is what a word is. It's definitely up for debate. Depends what you want to do next. You might just split on white space, but then you end up with punctuation in the words. If you split all the punctuation up, then a word like can't might be split into 3 different tokens. So you really got to think about what you want to do next and make some careful decisions on what kind of tokenizer to use. So once you've got your words, you can do language modeling. And what that is looking at the words in context, you can see you can map those words into vector space using libraries like Word2Vec, Club, and GenSim. And that gives you some interesting kind of vectors you can do math with. So now words are computable. And in this example, you can take a vector for the word king, subtract man, add woman, and you're going to end up somewhere next to queen. So that's similar for all these kind of male-female word pairs. And then you can see some more examples here of kind of how words are related. And then we've got an English to Spanish example. And you can see the word distribution is very similar in both languages for these vectors. And you can see that for some reason dog and cat are talked about very differently. So once you've got your words, you've got your language model, you can do topic modeling. So this is if you have a whole bunch of text, there's topics in there somewhere, you don't know what those topics are, how many there are. You can use a library like GenSim or scikit-learn to cluster by similarity. And so here, someone applied a whole bunch of different, they used a whole bunch of different newsgroup texts, and were able to come up with a bunch of different clusters. Once you have these clusters, you can look at them to figure out what the topic actually is. The algorithms don't know, but you can look at the common words and see what's there. So if you really want to understand a sentence in depth, you can do parsing. Spacy is a very good library for this. And they also make a tool called Displacy for visualizing the data. And another tool, a commercial tool called Prodigy if you want to make some training data. And this is, if you really want to kind of in-depth understand like the part of speech tags, how the different words are related, nouns versus verbs. So this is a Displacy view of that. And if you put it all together, you can start building up kind of NLU and chatbots. NLU is natural language understanding, and it can be used for more than just chatbots. Rasa is a very good library for this, but it gives you a way to kind of programmatically respond to dialogue that's just typed in. And so you're trying to figure out like what is the intent, what are they asking for, what kind of entities are they talking about. And I think there's a session on this tomorrow. So here's a brief intro to Rasa. You've got a query, and the intent is, okay, someone wants to provide an email, and you can extract the entity, and then you're able to compute on that and respond in an appropriate way. Thank you.
Thank you very much. So our next speaker is Sai Rampal. And please, Darshan, come up next. All right. Welcome, Sai.
Hello. Yeah. Hi, guys. I'm here to talk about scaling multi-tenant applications using Django and Postgres. So first, what I'll do is I'll talk about like different architectures in which like you can build multi-tenant applications, and then later I'll try to show an approach which scales right. So a quick intro about myself before I go ahead. So I'm Sai Rampal, and you can call me Sai. I'm an early engineer at Citus Data. Citus is an open source extension which horizontally scales PostgreSQL. A quick fun fact about myself is I have done like ping pong more than like software, so happy to get a challenge after the session. So okay, let's get into the talk. So how many of you know multi-tenant applications here? Okay, that's good. So an application which has like multiple customers, each dealing with their own data, can be termed as a multi-tenant application. You can think of most SaaS applications are multi-tenant. A classic example is a Shopify. So Shopify has like multiple stores, and each store deals with their own data. So the problem is, how do we like scale such type of applications? Generally, you might tend to start with an approach in which like you have one tenant per database or like one tenant per schema. This scales like well up to say like tens or like hundreds of tenants. It guarantees better isolation because you just point your like application to the right schema or the right database and you're all set. But then when you like go to scales at like say thousands or like 100,000 tenants, it becomes harder to manage. Suppose you want to do a schema change or a DDL change across like all these databases, you need to ensure that like all these changes are consistent. Number two, it becomes hard to like run your migration suites because like they would take longer to run. And number three, generally we have heard this from customers that like as the number of databases a single PostgreSQL database holds, it runs into like performance issues. So how do we solve this problem? So go with the approach in which like you have like a shared table approach. So you'd have like a single schema for all the tenants. So you'd have like multiple tables shared across like all the tenants. So you'd have something like a tenant ID or a company ID or a customer ID which represents like your tenant. This scales up to say like 100,000 tenants. And then you solve the problem of like slower migration suites because now it's going to be just like your migration suites would be on that particular schema. Next, we have observed that like Postgres also performs well because you'd see like better resource utilization, better index hit rates, better cache hit rates. But then one thing which is important is to, in such an architecture, is to ensure like all the ORM calls are always scoped to a single tenant. That's where the Django multi-tenant library kicks in. So this is a library which I built, and it basically automates all the Django ORM calls to be scoped to a single tenant. And let's get into how do we actually do that. So this is how it would look currently. So you'd have like a class, and then like here what I'm doing is I'm fetching a particular record for a particular ID. The Django ORM translates that to a simple SQL query with a filter on the ID column. But then once you start using the Django multi-tenant library, what would happen is that particular ORM call would be scoped to a particular store here because like the store is the tenant. Also note that like this particular scoping happens not only for like these simple ORM calls, but it happens for like foreign keys, references, joins, etc. Now let's get into like what are the benefits like with going with this approach and using the Django multi-tenant library. Number one, it minimizes application changes. Your developers needn't care to like add that particular tenant ID filter to all the ORM calls. Number two, it guarantees isolation. Your developers needn't care about like ensuring that like there is tenant isolation at the application layer. And number three, using this like model and like using the library, this model like lends cleanly to a distributed architecture with Postgres and Citus. So that's it from my side, and let's keep scaling Django. Thanks a lot. And yeah, one thing before I end. So we have socks for you. Please collect them after the session. So thank you. Bye.
Thank you very much, Sai. And I just have one small correction that I have to point out. Before I said that lightning talks on Sunday are at 8 p.m., which is incorrect. It's actually at 4:50 to 5:50. That's still not, yeah. So now you don't have more excuse. You have to sign up now, OK? Let's excuse us to sign up. OK, so our next speaker is Darshan. And please come up. And Yoko, please prepare yourself.
Hi, folks. My name is Darshan. You can remember me by remembering Darshan the Martian. This is a lightning talk on optimizing your Python software, also snails. But first, a joke. What does a snail say when it's riding a tortoise? Slow down. Whee! How is this relevant? It is. Let's continue. So this is what we'll be talking about. First, we'll go through how to approach optimization. Second, we'll discuss some tools to help us measure our code's performance. And finally, we'll end with some tips to help us optimize faster. Let's talk about how we approach optimization. If we're trying to make our code faster, where do we start? Would we optimize everything? That might work, but we're not going to do that because writing optimized code is hard to write, and it's much harder to maintain. So knowing our own code, would we optimize what we think might be slow? Again, that might work, but I want to offer a better approach. This is what we should do. Use a profiler. A profiler is going to show us where our code is slow. OK, now that we know what to do, use a profiler, let's talk about how to do it. Here are a few tools that we can use to measure our code's performance. There are a lot of tools in Python. These are just the ones that I like. Of course, there's cprofile, which is the built-in profiler. There's PyCallGraph, which is a visual profiler. And SnakeViz, which is an interactive visual profiler. And TimeIt, which is a built-in module to help us time small pieces of code. We can use it to compare implementations. What's faster? So cprofile, like I said, is Python's built-in profiler. It measures time spent in every function in 2 ways. That's total time and cumulative time. Total time is the time owned by the function, not including calls to other functions. And cumulative time, which is the time of the function and all other calls. This is an example of a cprofile output. It's a table. Each row is a call in the call stack. And like I said, it's measuring total time and cumulative time. Also tracked is the number of calls for that function. The per call columns are just the total time and cumulative time divided by the number of calls. I mean, it's useful, but it's hard to read. You can also run this profile through PyCharm if you have it. It's included with PyCharm Pro. On the right there, you can see a call graph. And this brings me to PyCallGraph. PyCallGraph is really helpful. It visualizes your profile information. So what you can see here is that we're calling the main function, and that's calling function 1, then function 2, and then function 3. And it's color-coded, so it helps you identify your slowest code. Another visual profiler is SnakeViz. This is an interactive visual profiler. It runs in a browser. I really like this tool, so let's go through an example of how to use it. So this is the visual representation of your profile information. Each arc represents a call in the call stack. As you go further out, you're going deeper into the call stack. And the time spent in a function is the length of the arc. The center here is the entry point to your code. As you hover over the center or any of the elements in the web page, it'll highlight, and you'll see information that's updated on the side. That's one call further into the call stack. And then what I can see on the web page is that that's the main function. If I click into that, it zooms in. And now I can see a deeper portion of the call stack. And I can see that that function is calling 3 functions. And this is what I like so much about SnakeViz, is you can navigate your profile information this way. TimeIt is a tool to help you measure small pieces of code. And it will help you compare what's faster. Again, this is really useful, so let's go through a quick example. Here I'm using TimeIt to measure the performance difference between accessing a member directly and accessing a property. And as you can see on lines 4 through 12, I've defined a class with a member P and a property prop. Then I use the TimeIt module to compare the execution time between the access of the member and the access of the property. And as you can see, it reveals that accessing the property is much slower. And that's how that joke ties in. That's the snail there. OK, so we've got an approach, and we've identified some tools. Let's go over some quick tips to help you optimize faster. Tip 1, you're going to be profiling your code a lot. So make sure that it's reproducible. You can use a unit test to kick off the profile, or just have an entry point for the profile. Tip 2, test every change individually. Use TimeIt to compare exactly what's faster. And of course, 3, don't optimize unless you need to. Like I said earlier, optimizing your code is slow, and then of course it's harder to maintain. So optimize later. So there you go. That's optimizing Python software in 5 minutes. Happy snails.
Thank you so much, Darshan. All right, so our next speaker is Yoko. Community from the inside out. Let's give a great round of applause for Yoko.
Hi, does everybody here know who I am? Yoko. Yeah, okay. Well, let's see. I'm Yoko. In second grade, I got chased down alleys for my name. So I got interested in psychology. This is a little bit different talk for a tech conference. It's about tech of this up here and community. And it's fascinating me, and it has fascinated me for a while. There was a time in Motorola I had, I was asked about a formal technical review program that made people read through code line by line, and I was so frustrated, I told an executive, "You're wasting your money." And he said, "Well, how would you do it better?" I said, "Hire a psychologist to teach us how to actually listen to each other." And 2 days later, he said, "I want to see a budget you're doing at 2,000 people." And I was really upset. And the funny thing about it is it worked. And I got awards, and I was surprised. And I ran a team of architects then, and they were so thrilled with all this great teamwork stuff that I said, why don't we apply it to architecture? Well, here I am 30 years later, and here's a funny thing. I'm realizing you can apply programming paradigms to team skills. So this is sort of my... Oh, what happened to my slides? My slides didn't get up here. Good, so I just get to talk. Oh, I loaded up a bunch. Okay, so that's great, because I get to talk, and slides get in my way. So we had a timer for me?
Go ahead, Matt.
No, what's my time?
You got 3 minutes and a half.
Okay, tell me when I have a minute left. Okay, so there's a neuroscientist, Jaak Panksepp, who died last year, who studied brain structures. I should back up a little bit. This all initiated this talk, and I'll be talking like a full hour about this at an open session on Sunday, and I talked at PyOhio a couple of weeks back about this. But this started from Brett Cannon saying in 2014 in a keynote, I don't remember if it was Python or Python Canada, but he said, I came for the language and I stayed for the community. And within about 3 months, Brett and I have been friends. I was a volunteer coordinator for PyCon for about 9 years. Within about 3 months, I saw the Go community mimic it, but they said we came for the technology instead of the language. And then a data group in Canada mimicked it. And I kind of talked with them. I said, why is everybody so excited about that phrase you made? What's the big deal about this? Well, my story to you is the big deal is we're wired this way evolutionarily for survival. And here's the thing I want to instill. Jaak Panksepp discovered brain structures that drive our actions, initiate our conscious thought. And they're actually surprisingly balanced and surprisingly predictable. And the concepts that he made about brain structures, there's a brain structure for seeking that originates supposedly from us looking for food, but it's also what makes Travis, my dear friend, so curious and always looking for new ways to do things. I think actually for most of the people I've met at PyCon, for curious about doing new things. This is an instinctual drive we have. And the reason people like, at least from my experience, the PyCon community is because we have a good amount of diversity, a good amount of openness, a good amount of encouraging people. The story I'm going to tell you is the brain structures are not in humans, they're in mammals, fish, birds, reptiles. In my full slides, I have an example of a human teaching a bee to do a specific task to get a nectar reward, and that bee teaching other bees and them innovating. So this runs throughout all of nature for one simple reason. And it's a sort of surprising architectural reason, I think. And the reason is our experience of reality is not reality. We hold models in our brains. We think we recognize friends. Sometimes we're wrong. People that have been blinded and had sight restored there's been reports, there's a famous one, a man who lost sight before 3, had his sight restored at 43, could never, 3 years later reported he could not recognize his kids from facial recognition. He did voice cues and other things. He could never recognize it. He didn't have the accumulated years of models. And my story to you, and this is the fascination of why everybody likes community, especially open community, is that evolution plants these things because we only have a close approximation to what the outside world is doing. That's the limit of our mental model. When we don't have the structures to interpret in our brain, for example, the visual cues to be able to see somebody are such a flurry of noise that we can't make sense of them. The only things we see are really our interpretation of it. And this is true for everything we do. Here's how it works in community. If I think I can't find a bug and I ask Travis, he'll spot something I missed. In community, when people cooperate, the competence of the entire community rises. That's the point. When the competence of the community rises, our approximation of what's going on in the outside world gets close enough for survival, which is why evolution so broadly favors it. So my story is, oh, this is really easy. How do we build a good community? Well, we get explicitly aware of our very personal nature of our experiences. So for Pi Vancouver, when talking with Brett, and I first talked about this, I gave the concept of cognitive encapsulation. If you explicitly say, my thought that the problem is like this, you set yourself up for asking, and what's your thought? And that openness is what builds competence. So if you come, I'm sorry I don't have the slide here. If you want to see my Pi Ohio talk, just look up my name in Pi Ohio and you'll find it there, or come Sunday at 11, and I'll talk a lot more about the data structures, how openness makes it inviting for other members of a team or a community like this, and how surprisingly well it works, and how if you don't watch it, you can get into the drive for community going into tribalism and fear-driven, which does not build competence. So there's this little tipping point to keep you into the positive. And my argument is that you can learn that as easily and specifically as you would a programming language construct. So thank you.
Thank you, Yoko. Community from the inside out. And actually, probably this is a good moment, as we're pretty much a little bit more than halfway through, to speak about the community. I stumbled across some tweets from Vikram Bhatt. Are you in the stage here? Vikram? There he is. There's Vikram. All right, so I really would love to quote some of his learnings that he shares. So in his tweet thread, he says, throughout this conference, speak to as many people as you can, meet new people, and make new friends. Host your own open spaces. We have open spaces opportunities here. Or host your own open spaces, or go to open spaces and meet people of things that you are interested in. And last but not least, attend the lightning talks, because there's a lot of information in these small bite-sized talks. Thank you, Vikram, for sharing your wisdom with us. All right, so the next speaker is Bonnie Shkulkin, and Shemaika, come up next. Thank you, Bonnie.
Hello. Let's see. All right, so I'm here. Let's see, my name is Bonnie Shulkin. I am a teaching engineer at Lyft, and I am also a testing enthusiast. I have a Udemy course on React testing, and I hope to make one on Python testing in the near future. I am going to be talking about fixtures in PyTest. I'm not associated with PyTest at all. I am just a fan. So the reason I like PyTest, it is a test framework that makes it easy to write small tests. So unit tests requires you to make a class for all of your tests. PyTest, no class is required. You can make complicated test structures if you want, but it also supports simple testing. All right, so now that we know about PyTest, here is the problem statement. Your tests are missing the mark. So this poor cat is trying to get some water. It's not working out. The example I'm going to use for this short talk, I'm going to have an example function that is going to make ASCII files out of, or to make files out of ASCII art. So you're going to give it a directory path and a subject, and it'll find the ASCII art, or pull it from somewhere and make a file. So if we gave it a subject of yak, we might get an ASCII art yak. And I think the exclamation points are what really sell it there. All right, and so now for testing, we're going to want to make a temporary directory to hold our ASCII art files. I'm going to be presenting some code here. 5 minutes is not long enough for you to actually read and understand the code, so I have helpful hints. Here we're defining the path for our temporary file, and here we are actually creating the directory. So here's my first test. I'm making my yak file, and I'm using my temporary directory. At the end of this test, I have one file in the temporary directory. Now, I want to test thoroughly, so I'm also going to test with a longer file, which is War and Peace in bubble letters rendered in ASCII art. And here, I'm using my temporary directory as well. Now I have two files in my temporary directory. Fine, so I'm testing, this is great, but I'm left with this problem of cleanup. So what's going to happen to the temporary directory? You could just leave it behind. That is messy and might mess up future tests. Not a great option. You could create a class to set up and tear down your directory. This is what you would do in unit test, but I don't need such a complicated structure here. You could create and delete the directory in every test, but obviously that's a waste of computing power. So enter fixtures. A fixture, it is a modular, reusable function, and it deals with setup and teardown for your test, but it also creates a resource. And in this case, the resource is going to be the string of the directory name. You can scope it, so you can either do it once per function. In this case, we probably want to do it once per module for our whole module that tests our ASCII art function. And this is an example of dependency injection. This means that we are separating the creation of our resource from its actual use. I can see people want to take pictures of that beautiful upside-down faucet. I totally get it. OK, you can also use fixtures for parameterization, for running the same test over and over again with different data, which I'm not going to talk about because I think I'm probably already at 4 minutes and 45 seconds. So, all right, the syntax. So first, you use a decorator to declare that you're making a fixture. Then you define your fixture. You give it a name. I'm calling mine tempdir here and giving it a scope. Then here I'm doing all that setup, defining the directory name and creating the directory. Now I'm returning my resource. My resource is that directory name. That's what I'm going to be using in my tests. And then I am going to do this teardown. And the teardown is going to happen at the scope, right? So if I have the scope as module, the setup will happen at the beginning of the scope. I can access that resource anywhere I use the fixture, and then the teardown will happen at when the module completes. So using the fixture, I pass it as an argument to my test function. And then I can use the name of the fixture to use the resource in my tests. And again, the setup, the teardown, and the resource creation are all going to happen at that scope, which could be at, so if you were using it for like a web client, you might want to have the scope be function. So it got reset every test function. In this case, I was having it just reset every module because there was no need to create and destroy the resource for every test. And one of the nice things about fixtures is they are modular, and so you can use several fixtures in the same test. You can mix and match. All right, so with fixtures, you have efficient testing. All of the water is going exactly where it's supposed to. Thank you.
Come on. All right, thank you very much. All right, so while our next speaker sets up, I have a few questions. So we have 2 great days of learning ahead. Is there any specific talk that anyone is interested in? Anyone? Some specific talk? Yes? Anyone in specific? All right, it's a talk called I Cannot Remember. Yes? Fantastic. Keras. Who uses Keras here? Lots of people. All right. Lots of knowledge sharing. I wanted to point out a couple of talks that I'm really excited about, actually. So Carol's talk on Jupyter Lab, I'm a really great fan of Jupyter Lab. And one talk from someone in this audience, Ethan Smith, right there. Great person, great person. Really excited to see your talk. OK. And while we continue setting up, why don't you tell me what your favorite Python 3.7 feature is? Anyone? Yes. Yes, data classes. I'm very excited about that, actually. Yes. I don't know if anyone here was part of the Python Christmas party. But it was really, really exciting to hear about data classes from Raymond Hedinger. Perfect, OK. You need yours. OK. And breakpoint. Python 3.7 has native breakpoint function. That's also really important. Pro tip. OK. Obviously, we have a little bit of technical problems, but I think we've nearly figured it out. Or maybe not. Oops. We're nearly there, I promise. All right? Is it working? I guess not. Is it working? No, it's not working. You're getting whatever you're set, but that's not. I'm not sending in the right screen.
Close all the other ones.
OK. Geez, I wish this was a Mac conference now. OK. Geez, I have no clue what to do. Anyone is a Mac expert here? Oh, maybe. Maybe we're there. Or maybe not. But now this display doesn't work. All right. So Python 3.7, data classes, OK, and breakpoint. And I also want to point out one really good tool that I've been using a lot, which is Black. I don't know if anyone has experience with Black. Pro tip, use Black so that you don't have to fight over style with your company teammates. All right. Black, really great tool made by Łukasz Langa. Pip install Black, and just you can effectively just use it on your files, and it'll format them automatically. All right. So here's a joke, which I think is terrible, but I'll still try to say it. Okay? What does the raw input function do? Anyone? Nothing until it is cooked and no longer raw. Well, you have to thank Jimbo Cave 09. Find him on the internet. And we still have not figured this out, and I'm running out of things to say. All right, does anyone here have any words of wisdom for us? Yes, someone has some words of wisdom. Announcements. All right. Ladies and gentlemen, improvised announcements.
Hello, hello, testing, testing. Okay, great. Yes, this is just an announcement. A friend of mine is putting on a hackathon at UCSF. His day job is a scientific researcher that looks at pictures. Difficult job. The hackathon is going to be about 3 different types of data. The first one is transmission EM microscopy. The second one is confocal. And the third one is proteomics, so looking at protein structure. And the job of all you wonderful people who are now going to come to this hackathon is going to be to save poor PhD and postdocs' lives from going 1, 2, 3 as they try and count all the cells in the picture. It's a 2-day hackathon. It starts on Saturday, I think October 20th. And if you want to write down somewhere, really important, the address to go and sign up for it, it is qbihackathon.ucsf.edu. I think that's right. Cool. If not, just Google those words. Thank you very much. It's going to be a lot of fun, so I hope to see you there.
Thank you. Anyone else want to tell us an announcement? I announce that Google is failing on us. Okay, I think we are nearly here. Here we are. Okay. Take this. Take this. I think next time we will try Windows. Maybe it will work. Oh, my days. I think we have done it. All right, let's give a great round of applause for Shamika. Or Shamika, I don't know. Shamika, sorry. All right.
Thank you, everyone, for bearing with me. I'm Shamika. Everyone hear me? Yes, okay. I'm Shamika Lamari, and I want to talk to you about the importance of exploratory data analysis. So a little bit about me to begin. I did my undergraduate degree at University of California, Berkeley in biology. And since then, I actually went on and did operations for 3 years. What I learned in that time was that I enjoyed biology because I enjoyed the analytics part of it, but I didn't want to do research in a lab. And I really enjoy operations because I enjoy taking time to learn processes and improve them. And so taking those two expertise and combining them, I feel is very perfect for data science, because data science is really how can you improve your businesses, how can you use data to make better decisions. So I went on and I self-studied for a while, and then I did a part-time boot camp, and here I am. So I'm going to go over a project that I worked on. So if you're not familiar with the data science process, here it is. So you generally will start off with a question, and you'll gather data that's available. Spend some time exploring the data. It's a really important part. And go on to do some models that can help you with predictions. And then you can also take time to do visualizations to help communicate your findings. So something that I am really passionate about or really interested in is TED Talks. And I really enjoy watching them because they're engaging and inspiring. And I find that there's so many different topics that I wouldn't otherwise know about. And TED Talks give me an opportunity to dive into those. So I decided to do a project on TED Talks. What I figured out was that so what I decided to do was go and find some TED Talk data. And so I used the Kaggle website. And so it had a data set with numerous features. And these were some of the features. And what I started off doing was narrowing down each of the features so that I could decide on what I wanted to predict. I realized that I wanted to look at something more numerical, so I took out some of the basic findings like names, speaker names, titles, things like that. And then I continued to slowly narrow it down. I did some analysis and looked at published date and film date and actually found that, surprisingly, there wasn't much correlation at that point with views. So I decided to focus on if I could predict TED Talk views. So I continued to narrow it down. I found very little correlation between the speaker occupation and the events, the different type of TED events. And so these were the final ones that I decided to use to help predict the TED Talks. So back to the data analysis, data science process. I got through these and I realized that it was time to model and go through and see if any of these new features could help me predict TED Talk views. I did some modeling and realized that I used Ridge and Lasso, and I realized that my models weren't coming out good. And then I also realized that even after doing adjusting of features, taking some out, looking at only a small portion of them, grid searching, adjusting test sizes, that I still wasn't getting a test score that I was hoping for. And this made me realize that I really needed to go back and do more analysis of each feature in depth. So some of the things that I realized were that a lot of these features, although you would think they were good indicators of whether or not they would be good for TED Talk views, a lot of them actually weren't. And so it took time looking at outliers and diving more into statistics to understand whether or not it should actually be included in my project. It came down to the tags. So the tags were actually you can view them as themes. So the themes for the different TED Talks were the most pertinent feature to be considered. And what I did with that was the tags were categorical, so I used a count vectorizer to change them into a numerical format. And so that helped me with coming up with using the regression model. So what I learned is that when in doubt, definitely spend way more time doing exploratory data analysis. It really helps you when you want to choose the right variables. It helps you so that you can choose the right model. One of the things that I realized afterwards was I wasn't quite sure why I chose to do a regression model rather than doing a categorical, since in the end, I could have made the project whether or not a talk was going to be popular versus unpopular, and I think that I would have probably got a better findings. And so the last thing that's why EDA is important is because it saves you time, so you don't have to go back and basically feel like you're redoing your entire project. I learned all of this, and so I'm sharing this because I hope that you will spend a little bit more time when you're doing your exploratory data analysis. And I want to leave you off with a couple of fun facts, since I'm sure you're all curious. So the most pertinent tags were technology, science, and global issues. And it makes sense that technology would be #1 since TED stands for Technology, Education, and Design. So that's good to know. So if you're ever considering giving a TED Talk, you might want to give your talk on technology. And some cool findings that I got from the project were the top TED Talks. For me particularly, I really love the talk on vulnerability. So if you're ever interested in checking one out, then this would definitely be one that you should consider. And if you thought my project was cool, definitely feel free to reach out because I am on the hunt for my data science position. So feel free to reach out. Thank you so much.
And the Wi-Fi is UCSF. OK, so we have the last two speakers of tonight. Our next speaker is Travis Oliphant. Most of you may know him because he made created and contributed to some of the best libraries used in Python today. NumPy and SciPy, and I'm sure a lot more. Yeah. And our last speaker, Aaron, is next.
All right. Thanks for your patience. Let's see if I can get this to show up. How are we doing? Look at that.
Wow.
Fantastic. OK, great. Thanks for holding out this long. I'm here just to talk a little bit about some of the new stuff we're working on. Yes, I've done a lot of stuff in the past. I just love doing new stuff, I guess. I've got something called Quantsite Labs. It's a spin out of Anaconda. We're kind of where we can continue the tradition of continuum analytics of just investigating new open source technologies, helping the community, helping build more community. One of the projects we've started there is something called XND. It's a continuation of basically array library components to help people build. There's this explosion of array technologies, right? So NumPy, and actually I'll talk a little bit more about this in my keynote on Sunday, but I wrote NumPy to unify the array objects in the world, and it kind of makes that effort look quaint, what's happening right now. We've got an explosion of array objects in the world. It's everywhere. And so my reaction to that is like, well, what kind of tools can we build to make it easier for those to interact with each other? And that's kind of what XND is, a set of low-level libraries. It's not something you should pull up today if you're not a developer of objects, if you just want to use them. XND isn't for you right now, right? But hopefully it'll make tools that will be for you in the future. So basically, XND is a result of what am I going to do now? All the problems that NumPy's been great, really love what it is, but it's got issues. It needs to be developed, it needs to evolve. What are the lessons learned from that? And one of the big ones is kind of a refactoring effort, kind of push some of the capabilities so they can be more extensible. There's challenges with the type system. Spent a lot of time on the type system inside of NumPy, but it can't be extended very easily. So why? What are the challenges of that? How do we improve on that? There's challenges with containers and where they run. Do they run on GPUs? Do they not run on GPUs? There's all these issues that show up. I've given talks in the past on some of the challenges that NumPy faces and how to go from there. So XND it's not the ultimate solution. It's a step in that direction to try to create components, a refactoring that then can be community developed to create better solutions. So that's what XND is about. It's a web page. It's got libraries. If you look in the details, the key parts of NumPy. Anybody know NumPy here? Yeah. Okay. Who's really feels like they understand the details of NumPy? A few? Okay. All right. Yeah, there's a lot of complexity sometimes on the covers, and there's a lot of great people that are going to keep maintaining it, actually, and do well with it. But it's got a D-type subsystem. This is a type system, basically. It's a memory type system. It's effectively arrays of specific memory types, and then it's got this great universal function system, and then a whole bunch of other functions, right? And kind of what Plurase is an organization that contains the XND concept. XND is the generic container. So XND isn't a container of a single array. It's really a way to describe any kind of container. The ND types is really the type system. It's something I'm really excited about. It kind of generalizes the D-type notion that everybody's jumped on top of. I see D-types everywhere in TensorFlow, and it's like, gosh, I wish you'd have talked to me about what you're doing there, because we've gone beyond D-types. Let's talk about what we should have been doing, TensorFlow and Torch. But everyone's just jumped on kind of the ancient D-type system, and there's some improvements we can make to that system so we can actually extend it to the future and not be trapped by our past. XND is a new array object, and then GUmath is kind of a multi-method approach. It generalizes universal functions so you can have more functions on top of more complicated data structures. So that's the concept. It's based on C libraries so that bindings could exist in Python, though I love Python and it'll be most easy to use from Python. You want to make it accessible so other languages also can take advantage of these capabilities. Anybody remember memory views? Anybody know what memory views are? A few people out there. You should all know what memory views are, because if you're doing anything with data and you're not leveraging memory views, you're doing it wrong, right? You're copying objects of lists around, and you're causing people headaches when they have to serialize data. Memory views intended to actually be a low-level protocol so data could be transmitted between different kinds of structures without overhead of copying. So that's what they were, and we actually wrote these the same time we wrote NumPy, basically so that we could generalize the buffer protocol and get NumPy in Python. When I had lunch with Guido, when I wrote NumPy, and I said, should we just make NumPy part of Python? And we both kind of decided, no, that would be the wrong idea, because Python has its own release cycle. The NumPy community is a different set of developers that exist in the Python world. So instead, we did this buffer protocol, which took the structure of NumPy and put it into Python. PEP318, you can look at it. It's kind of boring, but it's a lot of details there. So we worked on that. Stefan Kra actually helped finish the memory view object. I wrote the original contribution of the memory view object into Python, but then had to go kind of do a lot of other stuff. And so several people, Stefan Kra being one of them, helped continue the memory view implementation until it's actually pretty nice now in Python 3. XND is a generalization of that PEP. It's basically a generalization, so it's a data structure kind of concept across languages, across views, but it's definitely inspired by and generalizes that basic construct. So ND, one thing we didn't solve, and there's a mailing list, I remember this conversation very vividly as we debated between, well, should C types be there, should we use D types? How do we describe a pointer to memory? You think about have a handle to a bunch of data in memory, how do we describe it? And we kind of went back and forth. So we used a D type specification, we used a bunch of C types. We ended up punting at that time, and Guido said, just use the struct module. You ever heard of the struct module? It's got this archaic encoding of type with letters, Q's and F's and D's and so forth. So that's currently how that memory view object describes its types. ND types is sort of a better approach to describing arbitrary views of memory, arbitrary views of data. Arbitrarily nested, arbitrary types. It's a way to describe that. And then on top of that, you have a container, XND, which is then just a simple handle to a memory object defined by that low-level representation. So this gives you a way to define low-level data and have Python interfaces that are very simple and easy. That's the whole goal. And then GeoMath lets you do math on it. Tensor math, array math, they call it tensors. I've given in to that, even though I hate it. ND array math, it sort of lets you do high-level math on top of all that stuff. All right. So that's, most of this is the slides are kind of hard to really see this in. I've got a couple of examples in JupyterLab. If we look, any JupyterLab users in here? If you're not, you should check it out. JupyterLab is the bomb. It's going to be the rage. Everybody who uses notebooks today are going to be using JupyterLab tomorrow. So definitely should check it out. So this is just a simple notebook. This is all public and online. In fact, the whole project is public. There's a Gitter chat. All the communication happens in public on a Gitter channel and then via GitHub issues. So even though it's Quantsite supporting it, there's a Quantsite Labs. We're very intentional to have all our conversations in public, so there's not sort of some back channel conversation. You want to be a part of the conversation, join it. If you're interested in kind of thinking more about this kind of stuff and you're ready to dive in on some of how this works, jump in. We love your contribution, love your participation. But right now, the idea at the high level, it kind of would look like a little bit like a NumPy array, except it lets, I don't recommend you try to replace NumPy with XND. Just a disclaimer here, don't go around out and do that, nor say that I told you to do that. XND, it gives you some of the same capability, except it does things like strings. You have a type that's 5 times string. You look here, the type has the shape and the type together. It's got more kinds of types. Strings are UTF-8 strings. It's got things like ragged arrays. So you can have an array of arrays, and the raggedness is handled. So you have 3, 1, but these are all handled, but not just with Python lists. You can do this at speed and register a generalized ufunc that maps across that very, very quickly. So the same kind of speed you're used to out of NumPy, you can get out of this as well. So that's the kind of things. It allows categorical types, which is one of the key missing types currently in NumPy. You can have an array of types that are categorical, effectively integers with string lists. So that's the basic idea is you can imagine any kind of arbitrary nested complex data structure and then have a way to reference it in Python and define complex math over it. Effectively, it's the foundations for any kind of analytical processing system in Python is the idea. Make that easy. So that's kind of we've done some work this summer on merging Numba. Anybody heard of Numba? We're trying to know what Numba is. So if you oh my goodness, not enough people have heard of Numba. Go out and learn about Numba, right? Numba, you're gonna love it because basically it lets you write Python code that's as fast as C. You have your friends over there saying, oh, C, it's fast. You say, oh, I just decorator at JIT from Numba, now it's just as fast. Now, not arbitrary Python, but the kind of Python you want to be fast anyway is the array Python. You can write high-level loops, high-level things, do image processing with Python syntax, use Numba, and have it be as fast if you wrote C++ or C, right? Powerful, powerful system. Lots of people are using it now. It's got a lot of contributions. Super excited by it. We've been basically connecting XND to Numba so that you can basically define kernels at a high level in Python and have it be executed really, really fast. So you don't have to spend a lot of time writing a whole bunch of C code to make kernels on top of XND. early stages still. We've got a lot of, we've done some work. This works now. You can basically do a matrix multiply on top of arrays and then have it extend and work. Okay, I've probably taken all my time. So that's it. You can check out the webpage and jump in. Right now, like I said, it's kind of curious developers and people interested in the ideas only. It's definitely not something if you're, hey, I'm just a data scientist, I want to use things. You know, it's not going to help you yet, right? But if you come with ideas of a big problem you want us to help solve, and you want to be a user to kind of guide the development of the library, definitely show up. Definitely come and help us make it better. But that's XND. Jump in. Open source community project. Love to have you. Thanks.
Thank you very much, Travis. So all the people that didn't raise their hands, you got homework to do. Go home, check out Number, all right? And our last but not least speaker of today is Aaron Weigel, great friend of the community, great friend of SF Python. For the people that don't know, PyBay came out of SF Python, which is the Python San Francisco meetup, which happens twice a month. If you're interested in that, you should definitely check it out. Aaron is one of the organizers. We work together. If you actually have a talk or something that you'd be interested in speaking outside of this conference, feel free to write us an email. We have a big meetup page. Come over, check out our presentation night, check out our project night. There's a lot of really great events going on. All right. Yeah, no work now, no work.
All right, so
yes.
So you probably see that title, and you can tell that we saved the most exciting talk for last, because everyone here probably loves Excel. But this is actually about sort of like using a Python package I never really heard of, and I wish I heard of a long time ago when I was a grad student. That really made a big impact at our company. So just briefly, I'm a data scientist at Synthago. It's a CRISPR-Cas9 manufacturing biotech startup. So if you haven't heard of it, CRISPR-Cas9 is a really promising gene editing technology. And basically what we do is we synthesize RNA that helps tell CRISPR where to cut in DNA. And we also create our own pools of gene-edited cells. So we're doing both chemistry and biology. It involves a lot of systems and hardware engineering, so robots, and software engineering, which is mostly done in Python, although there is some of that JavaScript thing. And of course, we're doing data science and engineering there. So here's the problem we ran into. The head of operations wants high-level KPI metrics to report to the executives about how our manufacturing plant is doing. So I have the data to generate these, but in a 1,500 column, 300 megabyte CSV file generated from our internal Django REST API for manufacturing. We haven't hired a data engineer to fix this problem yet, although he is in the audience now. And I don't want to waste my valuable time once I generate this data clicking around in Excel to make graphs for an executive who is just, or for executives. And I had enough of that when I was a grad student, which is why I learned Python. So the solution to that is XLSX Writer. Whew, it's an open source Python package that's extremely well documented that allows you to automatically generate Excel workbooks with graphs and formatting without ever having to open Microsoft Office again. So here's just some data that I generated, just like some really simple data that I just made up about sort of like sales order date time, so when the order was ordered, when the manufacturing actually started on that sales order, when it was completed, and when it was shipped, and then things don't always go well, so there's the number of attempts and the pass rate. So I created this class called TPS report. So here's just some boilerplate stuff about loading the data frame in, processing it, so on, and just, so here we kind of have a method that just calculates different metrics. So how long does it take between when we get the order, when do we start manufacturing, how many hours is that, how many hours does manufacturing take, our total turnaround time, and then whether it was on time or not. And then you could resample that and calculate all of these metrics around overproduction, what our pass rate was, and so on. So here's kind of where the meat of this kind of comes in is you could call XLS Writer or several other packages like it through the pandas with Excel Writer, and then you could start writing just summary stats using Excel. So here we have writer.sheets, which creates a sheet in the workbook you're dealing with. And for one easy thing you can do is just freeze the top pane so the top row doesn't scroll down. you could add formats, which is particularly important for that date format. So if you ever dealt with Excel and dates, it likes to help the way a 6-year-old likes to help you cook, where you spend more time cleaning up after it than you actually spend doing anything. So we definitely want to set our date column using that before Excel decides to help. And then we can kind of go through with our different columns that we generated. We could set an integer format. With our percent format, we can actually set a nice conditional format so it colors it. So when our, for example, pass rate is low, it's red, which is bad, and when it's white, when it's good. And then we can set the decimal length. So here we could also just generate the graphs in Python. So we can just take a dictionary that sort of describes the different graphs you want to make and just generate them automatically with a for loop so we don't have to click for like 5 hours and then have to reset things over and over again. And then when we create the chart, we feed it a dictionary that basically tells what kind of chart type it is, maybe a subtype, kind of go through and get like the name. And Excel calls X values categories and Y's values. Don't ask me. And you can just do that automatically over and over again by feeding it a dictionary. So here, oh, try to find that. Hold on a second. And then we can just create this class. We can create our TPS report and calculate the metrics. We can have our graph dicts here, which just a few different things like overproduction, turnaround time, and so on. And then we can write and format that report. So just to show you that it actually generated an Excel workbook. See there, we have our pretty colored formatting that kind of shows our pass rate. Like, see like, oh, our shipments are on time more, that's good. So you gotta have, say, create all these graphs live right here, without ever actually having to touch any of the Excel interface. So we even created this nice bar graph that has sort of different colors showing different parts of that. So I just did that without ever actually touching the interface in Excel. So this seems like something really like sort of mundane and silly. Like, why is the data scientist doing it? It's a startup. Sometimes you just have to do silly things. But this had a really big impact on our company. So we put this on a weekly cron job, and we actually had several other reports we generated with this class. And it was sort of a useful stopgap solution until we could develop something more robust and functional, like a data warehouse in Tableau, which we're working on now. And like a lot of data science, we talk about like machine learning and AI, and those things are definitely really cool. But sometimes being a data scientist is more like being a data janitor, and sometimes you just have to go in and clean that data toilet. So thank you very much. Again, the company is Synthigo. The XLS Writer is great. It has great documentation. If you want to look at this notebook, I provided a link there. And by the way, if anyone knows how to do this in Tableau, can you please talk to me immediately? And we're hiring software engineers who know Django and bioinformaticists. And I guarantee you will not be asked to make Excel workbooks in Python.
Thank you, Aaron. All right, so this concludes our 10 lightning talks for today. But there is still slots for Sunday. Remember, Sunday from 4:50 to 5:50, we are still looking for lightning talk speakers. There's a board outside over there. Put your name down, put your talk title down, and I'll contact you. All right, thank you very much for being here.